I read about this in some random book by some MIT something, and it was like a very depressing sort of chapter, because like the entire chapter, they were like giving stories to all of these math concepts, and then they were like showing how they end up dying almost always, and like the probability of dying is 100% and stuff. And they're like, everyone is doomed to lose. And they ended the chapter by saying, okay, we have seen enough sad stories. Now let's see happy stories. And then the page is empty and the book is over. So that is how this thing started. But okay, to start off somewhere, let's try and see the answer to this question. So we have a bug over here. At least that's what the book said. Let's actually make it Pranav. Why not? Right?
Just to tell you, I'm the host of the meeting.
I'm co-host. Okay. Anyway, so a person is over here, and each second they randomly decide whether to move left or to the right. And there are, let's say, lots of blocks, right? So if you move right, you move over here. If you move left, you fall off the cliff. And once you've, let's say, reached over here, now again, next second, you can choose to go left or right. And there's a 50% chance that you move left and 50% chance that you move right at every point. And the question is, what is the probability that you eventually die? Like, and if you go this side extends forever. So you can keep going this way. So the idea is that if you get very far this way, it's quite unlikely that you'll ever die. But if you're at the very start right now, there's itself a 50% chance that you just die off on the first step. So in fact, we can say, let me just erase some of this, that the probability that you eventually die is at least half, because on the first step itself, there's a 50% chance that you die. And now in the remaining 50% chance that you reached here, there's a half.
Oh, I think I got
half.
it. Can I tell the proof?
What's the answer?
It's 1?
Yeah, that's the answer. However, we will wait.
Okay.
Yeah, so if you move twice to the left, then you die, etc. So like, you can probably bound it by something dumb, something like this, whatever. You can get that the probability is more than 2/3 or something. But as Pranav just gave away the answer is actually 1. So you are destined to die eventually. And why exactly you die, that's not really very clear yet. And we'll keep that a bit unclear for now. The main thing is that, we have sort of an infinite sort of thing, and we're not that used to working with infinite things. So let's make it finite. Let's say you die off from either side. Now you're over here originally, and you can go to the left or right. And if you move right from here, you die. If you move left from here, you die. So now the question is slightly different. The question actually becomes, what's the probability that you die off from here? Or, okay, first, let's actually find the probability that you die. That's not too hard. The idea is that if you don't die, what must be happening is that you go here. Now you go back here, and you keep doing this forever. But the probability that this happens forever is like half raised to number of times you need to do this. So like n and limit n tending to infinity, which is like 0. So the chance that you don't ever die is practically 0, because that means that every move you're making is sort of perfect, which is like obviously very unlikely. And but the real question, which is more interesting, is what's the probability that you die from this side, and what's the probability that you die from this side? And that's not as easy, but again, it's something that's doable. So let's try figuring that out. Anyone with any ideas? How can we do that?
Am I allowed to speak?
I mean, you solved the main question, so no.
I'm not 100% sure if my proof is correct though. I think I have an
Okay,
idea.
sure, you can answer.
This one is like, so suppose you die, the probability of dying from here is like X. So the one way is like you just directly go left. So you add 1/2. Then you go right and then left. And you reach the same state. So you calculate probability of that times X, like the idea which you can now elaborate.
Yes. So that's something that's a smarter way of doing what is usually infinite series ka summation. Let's actually just do the infinite series summation because it's not bad at all. But we'll see this equation thing also. The idea is that if you want to die from this side, either you just die off at the start, so 50% chance to just die off, or you go here and then you come back, which happens with probability 1/4, and then you die off from the side. So 3 moves are fixed. So 1/8. Or you go, come back, and then die. So 5 moves. Something like this. This is your summation. And then you can just evaluate this as 1/2 minus 1. This becomes 2/3. And on the other side, if you try to do this, you will get like 1/4 plus 1/16 plus blah, blah, blah. And this will come out as 1/3. But as Pranav said, a much cooler way of doing this, and something I was trying to advertise in my linearity of expectation class also, is always avoid, if you ever see an infinite summation, there is a way to avoid it. So the idea is, let's say this thing is P, and we can say that P is equal to either you die off originally, so half, or you go here, come back, and now it's the same position as the start. So you can actually say this. The idea is simple. Basically, you're either dying or you're coming back to the same situation, and now it's like into the original idea, because you can think of it as an independent event. So this part is kind of independent to this, and you can multiply them together. And I mean, you solve this and you get the same answer, P equal to pi 3. Okay, that's interesting. So probability that you die from this side is 2/3, and probability that you die from this side is 1/3. The issue becomes, like here there were only like 2 sort of things. What if I have 1, 2, 3, 4, 5, 6, 7, 8, something like this, and I start off over here, and both of these are cliffs. Now this is just scary. Like, how are you going to do it? And again, you want to find probability that you die from this side compared to probability. And actually, you can find the answer for any general starting point. Let's say you start in the middle or something. But for now, let's just solve this. Yeah, and now notice that if we can find some sort of general answer for n, we can in some sense take some sort of limit as n tends to infinity, and that basically becomes the question we have. Because the idea is that, like, you can keep going on the side, you will fall off, but that's close to never happening, or the probability that you die from this side. So if you take the limit of this answer, whatever you get here, which will probably depend on n, which is the number of steps here, you should be getting the answer, which is the answer of this question, the original one here. Yeah. So now this is our real question now. How do we calculate this sort of probability? So just to formalize it, actually we can make it as general as we want. So let's say there are a steps to the left. You're over here, and then there are some b steps to the right. So the total length is a plus b, which is n. And you want to find the probability of dying off from the left side. So from the a side. This is a question to think about now. People can take 1 or 2 minutes, come up with ideas, what sort of thing seems like a reasonable thing to do here. And also, if you were seeing the name of the class, which is why you shouldn't gamble. That's going to come very soon after we solve this problem. So you can wait for a bit for that. Also, if anyone has any ideas at any point, they can just speak up.
Add idea when the person is on the leftmost end.
Okay, what's your idea?
So the probability just takes the left step is 1 by 2. Ignore
Right.
that case. Suppose you take the right step. So now there are n minus 1 tiles. And you see the n minus 1 tile case in which he dies on the left end. So the thing is, when he dies on the left hand, it's basically you return back to the first thing. And then the probability then you die from there is p, if p was the initial thing. So like f of n equals to half plus half of fn minus 1 times p.
This is what you're saying.
Yeah.
Okay, that's actually very cool. I did not think of this originally.
This is correct though, right?
Yeah, this should work. Does it give the
Yeah,
right answer?
I was also thinking like a recursion for this. We can have like f of a comma b as the probability, and then like f
Exactly.
of yeah.
Yeah, that's similar to what I was thinking. Not a comma b, we can actually just call it f of a, fix a plus b as n. And
Makes
you can
sense.
basically say f of a is like either you move to the left on the next step, so f of a plus 1 by 2 plus f of a minus 1 by 2, something like this. But okay, first let's just see this. This looks interesting. So okay, when n is 2, what is this saying? F of 2 is half plus, let's just take this to the into 1 minus half fn minus 1. Okay, so this is what it's saying, right? So 1.
Yeah, this shows that limit n approaches infinity is f of n is 1.
Uh-huh. Is this even correct? I'm just trying to figure out. Wait,
Yeah,
what?
it's correct.
2 by 3, 1 by 3, 2 by 3, 4 by 3 by 4. Yeah, it's correct. Okay. Yeah, this works, but this only gives you for this case. And like, okay, if you want to solve this, I think what you'll get is n minus 1 by n, because if you put that, probably induct, so n minus 2 by n minus 1, 2n minus 2,
Yeah, it gives that.
n 2n by, yeah, n minus 1 by, yep. So this works. This basically says that if you're starting on the leftmost side, there's an n minus 1 by n probability that you die from the side. Or in terms of a and b, it's like, for this case, it's like a by a plus b. No, sorry, b by a plus b. Right? Yeah. But the cool thing is that this works out in general. Yeah. So let's try to figure this out in general. What we have is that if we define some sort of function, also, did people understand this? This basically, Pranav's idea is that on the first step, you either die off immediately or you move here. And now the question really is, if it was an n minus 1 grid, you want to fall off this side, because falling off this side would mean you're back here. And once you're back here, you can put back your fn into it in some sense. This is like the same idea for the 2 thing also, except it was clear that there's a 50% chance in that case. Now it's kind of depending on the previous answer in some sense. And then you just solve this and induct on n, and you get n minus 1 by n. But the more general technique for doing this would be basically if you start somewhere in the middle and you've defined f of a as the probability that you die from left side if you're a steps away from the left. So f of 1 is what Pranav found. F of 2 would be if you're on the second step from the left at the start, and so on. So we know that f of 0 is 1. Basically, if you've already fallen off, then you've fallen off. And as Pranav has shown, f of 1 is equal to n minus 1 by n, but we shall not consider that just yet. Also, we know that if you've already fallen off the other side, so f of, let's say, n, that's 0, because you've died. Or maybe n plus 1 is a better thing to say. Whatever. Yeah, the idea is basically that if you're at the kth step right now, after one move, there's a 50% chance that you'll be at k minus 1 and 50% chance that you'll be at k minus 2, k plus 1, sorry. So this is actually what it all comes down to, this recurrence. And now we are tasked with solving this recurrence. So we have 2fk fk minus 1 fk plus 1. And then you can think of this as, okay, maybe people like this form of recurrence is more, is equal to 2ak minus ak minus 1. And if you don't know how to solve recurrences, that's fine, because as you can see, as we will see, this is actually, there's a much better way of solving this, but for now, let's actually do it. So x square is 2x minus 1. So this has a double root at 1. This is the characteristic equation of the recurrence. Again, if you don't know how to solve general recurrences, that's fine, because we won't need it. But I want to just familiarize people with this idea, because later on we might actually need it. And the idea is if you have a double root, then the formula becomes a into 1 raised to n plus p n 1 raised to n. So basically we get that it's linear. And from there we get that it's actually whatever, n minus a by n, something like this. But there's a much better way of doing this, which is noticing that we can rewrite this as f of k plus 1 minus f of k is equal to f of k minus f of k minus 1. So they have equal common differences, and it's an AP. And well, you know the first term of the AP, which is 1, you know the last term of the AP, which is 0. So you know all terms of the AP. You can say it's 1, n minus 1 by n, n minus 2 by n, dot, 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 1 by n, 0. These are the probabilities of time. And the cool thing is that this was our original question with n tending to infinity. And this is like 1 minus 1 by n. This thing becomes really small. So the probability that you die off is 1, which is 100%, almost. What is really cool though, is that if you sit down and you find the expected value of the number of turns it takes you to die, that's actually infinity. Which almost feels contradictory, because like you've got that probability of dying is 100%, but the time it takes you to die is infinity, in which feels like, this feels like you never die. And that feels like you've broken probability in some sense. In fact, okay, let's actually calculate this. So again, the idea is going to be the same. Let's try to solve it for n, and then try to whatever, limit n tending to infinity. Yeah, so now quickly let's try and figure out with the same idea, exactly same. If you're starting here, what's the expected value of number of turns it takes you to die? And the idea is, again, you define a function f of a, which is again 50% chance that you go to the left. But now this function actually represents the expected value. And okay, you need to use linearity of expectation and stuff, but intuitively also, basically the idea is you've already spent one move. So it's either like you've moved to a minus 1, and now you have whatever the answer is, that plus 1, or you've moved to a plus 1, and again same thing. So it's almost the same thing, except this plus 1 now exists. So you now end up with something like 2f of a is f of a minus 1 plus f of a plus 1 plus 2. And again, we'll do the same thing. We'll rearrange. If you know how to solve non-homogeneous linear recurrence equations, you can do that also. But we will not do that because that's just sad. Yeah, this is basically maybe minus 2 here looks better. Yeah, so it's almost common difference, but the common differences are decreasing each time. So you have d, then d minus 2, then d minus 4, something like that. Basically, whatever was the common difference at the start, now you have that minus 2, then you have that minus 4, and so on. So we know that expected value of turns it takes you to die if you're already here, that's like 0 because you've died. And same way, if you're here, then also this time it's 0 because you've died. We're not caring about which side you're dying for. We're just caring how much time are you alive for. So yeah, so you get that if f0 is 0, let's say f of 1 is some c, and f of 2 becomes, this common difference was c, so you want to add in c minus 2, so this is 2c minus 2. Then you want to add c minus 4, so 3c minus 6, f3 becomes, and so on. So in general, what this becomes is like f4, let's see, is 4c minus 12. Basically, this 12 is what? 2 plus 4 plus 6. These are the differences. This was 2 plus 4. This is 2. So in general, it'll look something like fk is k times c minus sum of the first k minus 1 even numbers, which is k minus 1 into k. And again, now we can use the fact that fn is in fact 0. Or n plus 1. That's a matter of whatever you decide to call it. Let's just call it n because n plus 1 is unnecessary. Or okay, maybe n plus 1 is better. What? Let's just take n plus 1. N plus 1 times c minus n times k. N times n plus 1. And this should be 0 apparently. So you get that c is equal to n because this cancels. And yeah, now if I just write this down properly, the thing in general becomes k into n minus k minus 1 into k. So it becomes something like k into n minus k plus 1. Or okay, because I took the n plus 1 thing, but whatever I was hoping to come to was k into n minus k, which is like a into b in some sense. So distance from the two ends ka product. Okay, there could maybe be constant factors of b plus 1, whatever. But the idea is now, in your case, the thing looks more like 1 into n, where n is tending to infinity. So the expected value of turns it takes you should be infinity. But then you're guaranteed to die with 100% probability, which is like very weird. And one possible explanation to it, which I think is the actual one, is it's basically because if you take sigma 1 by n raised to half, this does not converge. But if you take sigma 1 by n raised to 3 by 2, this converges. So in general expected value, the entire idea is you have this extra n into p kind of thing, right? You have whatever k into p, k, something like this. This is the expected value. So this k creates this extra n factor, which makes this thing diverge. But this thing is just p of k, so it converges, in fact, to 1. So no, it's not equal to 1. But yeah, now we'll get into the cool stuff. Let's look into gambling. Okay, this is quite cool. So let's say you're at a gambling shop, and it's kind of like the same work, but you'll see why very soon. You start off with I don't know, let's keep it rupees actually. Let's say you start off with 100 rupees, and then every second you either get plus 1 rupee or you get minus 1 rupee. And if you ever reach 200, you're happy and you just go, because like my life goals are achieved. But if you ever reach 0, then also you have to go, because now you can't play more. So you want to find the probability that you reach 200. Do people know intuitively what the answer should be over here? And like you can almost prove it also. Like the idea is that you start with 100, you keep playing until you reach 0 or you reach 200. And this thing is sort of symmetric. So there's like a equal sort of chance that you end up losing $100 eventually, and equal chance that you end up winning $100. So you can say that there's somewhat a 50% chance that you win. And also this is sort of like your drunken walk, because you're now trying to die off from this side, because this is what you really want. But then this is what's happening. So every second you're either moving to the left and reaching 99, 98, or you're moving to the right and getting 100 and 102, and so on. So this is actually identical to what we saw earlier. And right now it's only 100, but let's say you started with, I don't know, 1,000 rupees, and you play till you reached 1100 or you reach 0. And now we had seen that the answer was like n minus a by n. N is 1100 here and a is 1000. So this thing comes out to be like one, wait, what? Oh yeah, the probability that you end up 0. So actually what we want to find is this side. So probably just a by n, because 1 minus that. So this is what we're looking for. This is like around 90% chance. So you have a very good chance of winning $100 if you get into this game. And in fact, if I start with, I don't know, $10,000, now I'm almost guaranteed to win my money, because now your thing will look like 10,100 and 10,000. So this is like 100 by 101. That's like almost guaranteed that you'll win. Only very, very small chance, less than 1% chance that you don't win. And you'll ask me, Rushil, your entire class label, that was you shouldn't gamble. But now you're proving that, you're almost guaranteed to win $100 if you just start with enough money. So what are you really doing? The issue is gambling is not really this fair. What they do in gambling is they have this thing called to the house. Like house also should earn the money at some point. So what they say is there's not a 50% chance that you win money and 50% that you lose money. Instead, it's like 18 by 38 to 20 by 38, which is like kind of like 48 to 52, which seems very similar. So like, fine, barely a difference, right? But apparently that makes such a big deal that you'll never believe it. So okay, I've not seen chats. 50-50 probability changes after every output. No, 50-50 I'm not saying is the chance of you winning. I'm saying in a second you either lose $1 or you 1 rupee, or you gain 1 rupee, right? And right now that's happening with the 50-50 chance. But what if you're more likely to lose 1 rupee? So there's a 52% chance that you lose 1 rupee and only a 48% chance that you gain 1 rupee. And now you want to calculate the same thing. But the thing is slightly different. So let's say again, we start with 1,000 rupees. Earlier we saw chance of winning was like around 91% or something like that. And now we want to calculate the exact same thing. So people can put in their guesses for what they think the answer is going to be. Meanwhile, I'll just get this thing on charge quickly.
This sort of reminds me of like the classic example they give while teaching Bayes' theorem about like the vaccine and positive, like false positive, false negative, and things like that, where it's like very non-intuitive with the probability of like it being like I don't remember the exact details, but yeah, it sort of reminded me of that.
Sorry. I was not listening. Can you repeat?
And this sort of reminded me of like the example they give when teaching Bayes' rule, right? Like the vaccine or like some kind of medicine thing, or like oh sorry, the test they like the test of having like some disease,
Mm-hmm.
and
Oh,
then
it's
they
the
give
one where you have false positives and stuff.
yeah.
Yeah, that's also quite cool. But okay, any guesses? Like random, like earlier it was 90%. What do you expect now? I've also given you hints that it is going to be low. So okay, maybe let me make options. A 1%, B, okay, let's also keep slightly higher, 10%. Now you know it's not B. 0.1%, D, 0.01%. Okay. Yeah. And earlier it was 90%, just to make it more this thing. Guess options A, B, C, D. Everyone put something on chat. Come on. Also, Summer, to answer your question, can we find explicit formula from any recurrence? No. I mean, probably you can, but like at least there's no general way of doing it for every recurrence. Okay, someone is guessing D, Pranav. Someone else, come on. A, okay. Yeah, that makes sense. That's the first thing I wrote. Maybe that was just the right answer. Sai, what's your guess? A, okay. The answer, by the way, is, I'll just copy the exact number. That's fine. But also, answer is none of the above. Answer is 1 in 37,650. So, if you do the math, that's like 0.00001 or something like that, whatever, much smaller than any of these. This is like 10 raised to what, -5, more than that, 10 raised to, between 10 raised to -5 and -6. Okay, fine. I started with 1,000, that was not enough. Let's say I started with this much money. Now though I should win $100, right? So now let's put in the 4 options again. Or 5, let's say. Let's keep this also an option now. Yeah, now this is a more reasonable question, right? Which one of these? A, B, C, D, or E? You started with this much money and you keep playing until you hit either 0 or you hit just 100 more than this. That's barely anything. And you keep playing until one of those happens. So what's the probability that you win? D. Okay. Yeah, makes sense, right? It's getting better. Yeah, the answer, by the way, is the same. Independent of whatever money you started with. Of course, you start with $1, the answer is going to be even lesser. But for all large enough starting numbers, the answer is this. Like, irrespective. It only depends on 100, the amount you want to gain. It does not depend anymore on the amount you start with, which makes no sense. Like earlier, it was so dependent. Like you went from 50 to 90 to 99. And now it's just stuck at 0.00001. And that's like absolutely insane. And that's all because of what is this 2% of a difference? Nothing.
Wait,
1
I
by
have a
19 will
question.
be changed. Yeah.
Is it stuck at like 0.001 because like is the probability the exact same or did it change by a very small amount?
So what you'll end up showing is that it's some exponential plus 1 by some exponential plus 1. These exponentials are so big that you can ignore the plus ones. And if you ignore the plus ones, then it's constant. But these plus ones don't matter at all. Like this is of the order 10 raised to 10. And it's of plus 1. So, I mean, of course, it changes. It's not equal, but
Yeah, okay.
changes by less than whatever, 1 by 10 raised to 10, you can say. Something like that. So yeah, but for our purposes, like, okay, for a mathematical purpose, of course, it has to change. It can't be the exactly same thing, but yeah, it does not change as such. And let's actually try and figure out what's going on. So we define f of a again as now the chance that you go to the left is, let's say, p, and the chance that you go to the right is 1 minus p. So p times f of a minus 1 plus 1 minus p times f of a plus 1. And again, we think of this as our thing. Okay, I think I messed up a little bit. I should have kept right as p, because at least that's the answer I remember. So it's better if I just end up with that. Otherwise, I'll be very confused.
F of A's probability you end with plus 100, right? Or you die.
Yes, f of probability that you, okay, we can keep it either, but because let's keep it as the probability that you die with plus 100. Otherwise, you'll get 99.99999. It's better to have 0.001. I don't know.
Okay.
Okay. Yeah. So
You
this is
die
the
with plus 100,
probability
die
that
with
you
0.
die with plus. You win with plus 100.
Yeah, win the plus 100. Yeah.
Yeah. You don't die because you got plus 100. Usually, at least. Who knows? Yeah, this is sort of the quadratic we have for the recurrence relation. And I won't do these steps in too much detail because it's really, really bad. But just to find the roots quickly, you can notice that 1 is a root because p minus 1 plus 1 minus p is 0. And so other root has to be 1 minus p by p because product of roots is c by a. So these are the roots and they're distinct. So this time you don't have that exception sort of case which happens in recurrences. And you can say that this is the general answer. Now we just want to figure out a and b. And we know that for the base value, f of 0 is like 0. And f of, yeah, so you want to probably define a plus b, which is a is, or n plus b maybe. No, a plus b. Then I shouldn't use a here. Okay, n plus b. And then imagine n's were all over here. Whatever. The idea is that f of n plus b is 1. This, if you start with 1100, you're done. You're happy. And now you just put in these two things, figure out what a and b are. Just for the sake of, let's just see. We get a plus b is 0 and a times 1 minus p by p. Can I mess something up? Probably not. N plus b plus b is 1. Whatever. So you can calculate a and b. You can do stuff. And I will skip to the final answer because I do not have the motivation to actually solve this recurrence. What you end up with, yes, it is 1 minus p by p raised to something. I'll figure that out. And 1 minus p P is 1. These two I need to figure out. What is this? If I take this as I think A, or rather N and N plus P. Is this correct? Is P 18 by 38? 10 by 9. Yeah. And P here is whatever, 9 by 19. I don't know why they always write 18 by 38. Like, you can cancel the thing. Like, why not? I guess the idea behind writing 18 by 38 is like, no, even that is not valid logic. I have no idea. Yeah, it's very weird. I don't know. I guess 18 by 38, the idea is like it feels close, like 19 by 38 is your half. So they want to say 1 by 38 less than that. I don't know. Whatever, they have some ridiculous reason for doing that. And the idea is, okay, first of all, notice that if P over here was half, then what you would get is 1 raised to n minus 1 by 1 raised to n plus b minus 1, which is 0 by 0. And you can figure this out by limits. So if you actually take the limit, you'll get n by n plus b, which is actually the answer for when p is half. And now, however, what happens is when you have 9 by 19, this thing becomes 10 by 9, right? So you have 10 by 9 raised to 1000 minus 1 by 10 by 9 raised to 1100 minus 1. And 10 by 9 raised to 1000 is like so big. How big is it? Let's actually figure out. It's like 1.1 raised to 1000. You can take logs or something, but I don't know. I'm too lazy to do that stuff. Whatever, it's very big. So we can ignore these. And the idea is that this just then becomes 10 by 9 raised to minus 100. So 9 by 10 raised to 100, which is what was written here. And this is in fact independent of whether we started with 1000 or 10,000. Just if you start with very less money, then those ones start mattering, at least for the numerator. So there you can't apply this logic. But if you start enough with enough money, it's sort of equivalent. And that's really brilliant, sort of. And this is why you shouldn't gamble. They're making you think that you have a 50% chance of winning or a 91% chance of winning, but actually your chances of winning are 0.0001. But yeah, now let's actually do one very cool question. I think Atul showed me this a couple of months back, and it's sort of based on a similar idea, though it's quite different from what we did just now. It's like you basically have a circular table and you have 1, 2, 3, 4, 5, blah, 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 n, and there's a wolf over here and all others are sheep. So sheep, 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 sheep. All of these are sheep. And wolf is like a random person, except now he's in a circle, so he'll never actually die. The sad part is the sheep are the one who are going to die, because if the wolf goes randomly to the left and he sees a sheep over there, he eats the sheep. So the sheep dies. And now again, he can choose to go left or right. If he goes to a place where there is currently no sheep, like over here, then he just goes there. But if he goes, let's say here now, and he sees a sheep over here, he eats it. Then he could go here and eat this, then come back here, see no sheep, then go whatever. He does a random walk on this sort of circle. And you are one of the sheep. And you're obviously very scared of dying. But you want to make it so that you're kind of the last person to die. And the other sheep are like, they all want you also to die last. So they say, okay, sheep, you can sit wherever you want. So now it's your choice. You want to sit somewhere, wolf is at 1. You want to sit somewhere so that the probability that you die is minimized. Like the probability that you die last is maximized. Or okay, to make it more interesting, maybe we can say like if wolf sees that you're the last remaining sheep, he feels sorry for you because that would mean that you'll go extinct. So he doesn't eat you. So you want to be the only sheep that survives. So where should you sit?
I mean, the original question was wolf only eats n-1 shifts, there are n.
Okay, yeah, that's true. That was the
So where
original.
should
So
you
wolf
sit?
stomach gets full after he eats
No,
n-1 suddenly.
yeah. So where should you sit so that the probability to die is minimum?
Uh-huh. Yeah, that's also a cool way of putting it. And yeah, I'll put in some options again. So option 1 is 2 or n, which are equivalent, like the ones adjacent. Option 2 is opposite, like whatever, diametrically opposite. I don't want to figure out whether that's floor of n/2 or whatever. Option 3, I don't really have other options. These are the only two reasonable options actually. Let's just say, I don't know, does not matter. Let's say does not matter. Okay, people think 2, right? Anyone thinks it's 1, or anyone thinks it's 3?
Intuitively, 3 doesn't make sense because like the
Yeah,
wolf eating 2 before 3 is like more likely than 3
that's
before
true.
4.
That's true. So what's the guess? It's 2? Are people sure? Lock kiya jaye? The
No,
answer is
I
3.
3, yeah.
So yeah, intuitively you're right. Like it seems much more likely that 2 will get eaten before 3. And yeah, I the answer is just 3. It does not matter. Sit wherever you want. Just don't sit at 1 because then you die straight away. And wherever else you sit, it's equivalent. Even sitting next to it, there's equal chance that you die off as last. And the main way of like convincing yourself that this is true is that it's not just that you got eaten up, it's that you got eaten up last. Like everyone other than you has to be eaten up. And even if you're next to him, like the fact is that you want to whatever go through this. Okay, I'll just explain the entire idea. The idea is that if you are in fact the last person to be eaten up, then what happens is that you had a neighbor and you had another neighbor, which is possibly the starting point of the wolf, but that does not matter. And what must have happened is the wolf eventually reached over here, but decided not to eat you. Instead, he decided to go the other way, all the other way, and eat this wolf also. Of course, he could have like shaked around a bit, like just mixed around, but eventually he reached here and ate this person, and you were the last person to serve. And the main sort of idea here is that if this is your left neighbor, let's say this is 1, 2, blah, 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 n, then 1, 2, blah, blah, I can actually put this on a line and I can think of it as the cliff problem. So you're starting here. If the wolf falls off this side, that means you die. But if the wolf falls off this side, that means your other neighbor dies, which means that you're the last person to survive. So you want him to fall off from this side, which happens with probability 1 by n, we've seen. Whatever, a by n, which is 1 by n here. And the idea is that irrespective of where you are, at some point, one of your neighbors must have been eaten for you to be the last person to survive. So if you ignore everything that has happened till now, you can actually start off the game so that you are next to the wolf. And the game is then equivalent for everyone. And still, it feels hard to convince yourself that this is true. Okay, I mean, fine, logically correct, but then it's kind of weird, right? Like if you're far away, then it makes sense that maybe he did something like this. But if you're close, the only way is that he must have done this. But the idea is that even if you were far away, he must have gone here, and now it's equivalent. And now he has to do the full route. So the answer turns out to be that it does not matter when you start. Which is very cool. Okay. And yeah, this is what the book was all about. Like the book is like in this chapter, first it's like this guy is destined to die whatever he does, very bad. Then they came to the gambling, they were like, you are also destined to lose whatever you do. Then they came to the sheep, and they, yeah, I'll send the link for the book. And the sheep is like, wherever you die, it's equal chance that you die, there's no point in your life. So it's like absolutely trying to depress you or something for no reason. But yeah, it's kind of cool. uh I also have some other cool problems on this sort of thing. It's not really relevant to what I've covered, but this was supposed to be a slightly shorter class because of course I don't have infinite content on this. It's a very specific sort of thing. But there was this cool problem which is like, if you don't know graph theory, this is kind of sad, but um we don't use anything like too fancy in graph theory. Basically the idea is you have like a set of vertices which are like points for you, and or cities you can imagine, and some of these cities are joined by edges. And this is a tree, if you know what a tree is, which is basically that there's only one path between, exactly one path between any two cities. So your graph looks something like this. And you start off over here, and every time you just randomly decide, okay, let's say you start off here actually, like you have four options of where to go. You just randomly decide where to go. You have 1/4 chance of going here, 1/4 of here, 1/4 here, 1/4 here, and you keep going all your life until you reach your favorite city, which is, let's say, this city. So you want to show that the expected value of the number of steps it took you, so it could have been like blah blah here, 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 something like, and then you have to take the average across all possibilities. And the expected value that you end up with, that is always an integer. And in fact, it's like an integer that I can tell you what the value is. Okay, no, I can't actually. Like I can tell you, I can figure it out with enough time. Yeah, and this is like very random and weird. Also, if you see the question we had earlier, that's actually a special case of this, because you can think of it as points, and there the expected value was k into n minus k, which is always an integer. And like there your graph was like a line graph, but now you have like a general graph, and you want to show that the expected value of number of steps you take is an integer. And again, like there are two ways of doing this. One is to make up a very big double summation series, or you can be smart. But I will not solve this question here. This is for you people to try. Do any people have any doubts about today's class? Something they didn't get or something they want to talk about? If not, I'll also share the book thing. This is that chapter, at least I'll share.
What exactly, like, I'm just curious, what exactly about the fact that it's a tree do we use for proving like the integrality of the expected value?
Huh, very good question. I okay, so what I used is the it's sort of a hint, but not really as such. The idea is that if you want to find expected value from here to here, that's equivalent to finding expected value from here to here plus expected value from here to here. So if you can show that each of these are integers, which you also need to show because you want to show it for every pair, you'd be done. And the issue is, if you have a cycle, now there are two ways to reach it. So you'll also have to take that into account, which is kind of messy. I'm not sure. You want to either get to it like this or yeah, I'm not sure. I don't think this works out, because if it did work out, it would be the problem.
Okay, that makes
Like
sense.
let's see, for a triangle, right? What's the chance? What's the expected value of getting from here to here? Uh, So by symmetry, it should be like e plus 1 into half plus 1. This is it this? What does this give? 3 by 2. Oh, this is an integer. This is 3. Okay. Oh, we got lucky. Maybe 4 cycle is a contradiction. I don't know. Oh, this is interesting. Okay, good question to think about. What happens if you're in a cycle? Yes. But yeah, for your answer, like we use the fact that you can add stuff up across because there's only one path. If you have multiple paths, that kind of becomes a worry. But maybe it still works out. Who knows? Maybe that's an unsolved problem. Maybe you can write a research paper on this. Okay.
Thank you. Yeah.
Chalo. I think I shall stop recording now.